of course, did not have any sound for any of that. Well, that is my bad. We'll go through it really quick again. Wow, that's embarrassing. So I'll skip me. You guys all know who I am. Everyone that's come to the meetups before. Um, this is a quote. You guys can read the quote. Let me just make sure. All right, that was bad. So this is usually easier when I actually have someone there to help. I can test that the sound's actually working. So I'm sure you guys read along in this slide. I'll just kind of sum it up. Your progressive web apps, they're responsive, they can work offline, they're app-like, so you kind of get an app shell while you're loading your application, so you're kind of not just sitting there on a white page. They're always up to date, you're always using the latest technologies, they're safe, you're using HTTPS, they're discoverable, so search engines will be able to index them, and your application will be on the Google search results, all of that, and they're installable, so users will be prompted to save your application to a home screen, and you'll be able to just kind of click that application and then quickly be able to view your application without the toolbar and all of that kind of stuff. And then I was talking about Lighthouse, how this is an open source tool built by Google. And basically what this does, it will analyze your application for performance, accessibility, how it rates as a progressive web app, and a lot more. This will give you a lot of key indicators in your application, how it's performing, when your first time to paint is, do you have any scripts that are taking a long time to load in the browser, do you have any styles that are taking a long time to render, all of this kind of stuff. So even if your application, you're not aiming to be a progressive web app, or you don't want to use service workers or anything like that, this tool is very good at nailing down key aspects of your application that's downgrading performance. So you can share these reports, you can run them, and then I would highly suggest kind of just doing this on a monthly basis or whenever you have a release of your product to make sure that your performance scores aren't going down when you're releasing new versions of your software. So I would consider that sort of a regression that you would kind of have to fix before you actually go GA with your new release. So we're going to take a look at what this Lighthouse project does. So we're just going to take a look at the Polymer project shop because they're aimed as a progressive web app, and we're going to see how they score. So everyone has smiles. We're good to go. We still have sound, so that's good. So this is the Polymer shop. They're kind of just a shop right here made with Polymer, and you can kind of see all of the different things that you can buy and Google is selling. Pretty cool. We're going to go ahead and use the Chrome extension version of Lighthouse. So I just installed it via the Chrome extension store. Lighthouse is up here, and then there's an option where you can pick your different categories that you want to actually run with. So here we're going to keep them all checked. But like I said before, if you didn't really care about being a progressive web app or SEO or anything like that, you can uncheck them and kind of cater your report to how you want. If we were to look at it in the Dev Tools, it's just under the Audits tab, and then you can perform the audits just like this. So we're going to go ahead and run this. I'm going to hit Generate Report. And when you generate this report, it's going to take about 60 to 90 seconds. And it's basically going to throttle the application so it seems like it's performing on a 3G network to see how your application handles slow or non-performance networks. And then it's going to try a whole bunch of different form factors to make sure your application is responsive. There's mobile form factors and all of that kind of stuff. And then we're kind of presented with a report that looks like this. So here, this application scored a 91 on the progressive web app. It did not, it scored a 64 on performance. I tend to see this performance kind of fluctuate depending on if things are cached or anything like that in your browser. So we see up here in the progressive web apps, we scored a 91. We failed one audit. So the service worker that is on this application does not register or serve up the manifest start URL. So the service worker doesn't know how to actually prompt the user to install the web app to their device's homepage. So that's one audit that we failed. But it did pass 10 audits, so it registered as service worker, it responded correctly when offline, we're using HTTPS, or redirecting any HTTP traffic to HTTPS, it loads okay on 3G, and then we have some manifest properties, a manifest.json file that has a whole bunch of properties indicated based on the splash screen, colors, etc. And then we look down here at performance, and we see we get a really cool graph on the time it takes to be a first to paint. So we see that it took about, it says it took about 3,800 milliseconds for content to actually appear, and it was interactive at 7 seconds. So basically the user sat there, they saw it, but they couldn't actually interact with our application until about the 7-second mark, which we kind of need to work on. And the cool thing about the performance, it tells you all of the things that you need to do to actually improve this number. So here we need to make sure to use properly sized images. So probably what's happening is we're using oversized images and we're using CSS to resize them for us. So that results in a larger payload that we need to render before to load before we actually render the page. So if we used proper image sizes, the size would be smaller, and then we'd be able to render it better. There's a lot of off-screen images, so we can do lazy loading those off-screen images to make it faster to react. And they have a lot of documentation where, like, if you're curious how to do this lazy loading off-screen images, you can click learn more, and this takes you into a nice documentation that walks you through sort of how to do that, which is pretty nifty. And then optimize the images. So we see that we scored pretty low because of a lot of the images that we were using. If we kind of fix that up, then our performance score will go through the roof. It checks accessibility. So the audits that it checks to make sure that we're using element attributes, we're using the ARIA attributes, they have names, images have alt tags, we have meta tags, etc. So screen readers and all of that can use our application as well. It has a section for best practices. So here we're not using passive listeners for scrolling. We're using deprecated APIs. And then here are the 14 things that passed. So we're avoiding application cache, we're avoiding the web SQL, we're using HTTPS, we're avoiding document.write, and a whole bunch of faux pas that sort of are deemed not so good to do inside of your web applications. And then finally, it does an SEO audit. So it just checks to see how good your web application is fitted for search engine optimization. So we see that we don't have a meta tag and we're using eligible font sizes. So you'll kind of get this on a lot of web applications because this basically says that they want all your font sizes to be 16 points or higher. And a lot of people will probably set their defaults to be like 14 or 13. And even this application has smaller fonts than 16. So, but the past audits, you'll see that it has a title, meta tag, successful HTTP status codes, all link have descriptive text, and things like that. So before we jump on to the next stuff, I'll just check to see if there's any questions. Good to go. So now let's actually do this in an Angular CLI project. So I'm kind of going to walk through this. We're not going to kind of code all of this together. But basically what you want to do is you want to make sure you have Node.js installed. For this demo, I have the 9.4 latest release of Node.js, which installs npm 5.6. And then we do an npm install -g at angular/CLI. This will install the latest version of the CLI. I think the current version is 1.6.3. And then with that, in the command prompt, we're going to do an ngNew to generate a new project. And I'm just going to call this meow PWA. If you've seen a lot of my other talks, I kind of do always a cat-themed demo application for some reason. And then we're going to cd into that application. We're going to do an ngServe to make sure that our Angular CLI generated an application for us properly. And then we're going to update the UI to include some base behavior. So we're going to give it a nav bar and then a spot where we're just going to render a random cat GIF, and then a button to sort of update that cat GIF as we click the button. And then finally, we're going to push this to GitHub. We're going to deploy it to the GitHub pages. For those of you that aren't familiar with GitHub pages, it's basically just a really simple web server that GitHub gives us. It's like hosting. So we'll create a branch on our repository called gh_pages or gh-pages, whatever you want to name it. And then we're actually going to install another library globally called Angular-CLI-GH pages. We're going to build our application, and then we're going to use ngh. And what this does is it will take the contents of the dist folder, and it will go ahead and push it to our GitHub pages branch. And what that branch does is simple web server. It'll host anything that we have in there, and then we can go to the URL provided, and then our application's actually hosted, and we don't have to pay any hosting fees or anything like that. Pretty easy. So let's take a look at the code for this guy. I'm going to go ahead and just start him up. So I checked out my branch. If those of you that want to kind of follow at home, it's just under GitHub, and it's called meow-pwa under my GitHub, Godi. And then I have 4 commits on here for the 4 steps we're going to do, and then each one is a tag. So I clone the repository, and then you can do git checkout tag 1 or step 1, and this will check out at the initial project before we sort of add some of the steps to make our application a progressive web app. So let's just do an npm start, which runs ngServe, and we'll kind of just look at what the application is sort of at the base state. And this takes about maybe 20 or 30 seconds, or 7 seconds. We're going to go to localhost 4200. And we see our application is, like I said, it's a very simple application. There's no routes or anything like that. We have a nav bar where we're just giving the title of our application. And then we have a button where we can generate a new cat GIF every time we click on it. And basically what this does, we click on the button, and then it modifies the source tag on the image, and then we get a new cat GIF. So hopefully we don't get any cat GIF that is inappropriate. I've had that happen before, and it looks like we're getting some duplicates. But let's take a look at the code. Like I said, it's a very simple Angular CLI application. Everything was generated. We have our meow root inside of our body tag. And then in our app, we have one component called cat. The HTML of this, we're using materialized CSS. We're kind of just pulling that in. You see that referenced here in our style CSS. We're also pulling in normalized CSS to kind of give us reset our application to a default state. Our app component HTML just has our nav bar, and we're using our meow cat component. Our meow cat component HTML just has a row with a column that we span all 12 columns, and then an anchor tag up here. When we're clicking that, we're generating a new cat, and then a card, and then just an image tag where we have the source property bound to the image source. Our cat component, we see that we have a base URL up here for the cat API that gives you a random GIF. And then we have a list of all of our categories that we can pass to this cat API. And then on ng-on-init, we're going to go ahead and just generate a new image. And then when we generate a new image, we just take the base URL and we grab a random string from our categories array. So we go back to the application, and we see when I click this, we'll get a new cat each time. And then, so let's go back to the presentation or somewhere. So with this, we've done all these commands. We've went ahead and built our application using the ng build. We did -- prod, and then we passed it a base href to our build command. This helps us with when you host on the GitHub pages, you have to set the base href to whatever your GitHub project is. So our base href would be the meow-pwa, and then we use ngh, and that kind of pushes it to GitHub pages for us. So now we have our application out there. This is the very rough draft of our application, but we can go ahead and use Lighthouse to audit our application to see how we're doing. So I went ahead and ran this for our initial application, and you see that we're not doing so well in the progressive web app land. We failed 7 audits. We only passed 4 of them. Our performance was also pretty small, pretty low. We scored high on accessibility, best practices, and SEO, but we can always do better to get those numbers up as well. For the first step, what we're going to do is we're going to fix these 2 failed audits. So we're going to make sure that our application has a fallback when JavaScript's not available, and then we're going to make sure that all of our connections are HTTP, and then that'll kind of help our application out immensely. So the performance side, we see that now we have about a 2.7 seconds, about 3 seconds before the meaningful first paint, and then it's about 6.8 seconds until our application's first interactive. So not the best. We definitely can do a lot better with this. And then we see that we have some opportunities for our style sheets are we have some render blocking style sheets that we can kind of fix up to make our application more performant. So now we're going to do some updates to our application. So these updates, what we're going to do is we're going to add in an app shell. So what this means is we're going to add a loading message inside of our main component. We're going to mock out the header so we get some indication that the application's loading. This app shell is not meant to be interactive. It's just meant to kind of give some paint to the user faster, so he or she kind of feels like the application's faster than it actually is. So it's kind of like perceived performance. And then we're going to handle JavaScript fallbacks using the noScript tag. And then we're just going to go through our application and make sure that any place that we're using HTTP, we're going to use HTTPS instead, so that our application is more secure. So what I'm going to do for these is I'm not going to check out each different step and then peruse VS Code. What we're going to do is we're going to go and just look at the git diff on each commit. So if you're following along at home, you'll do a fill your server, and you'll do a git checkout step 2. And what this does, it'll actually check out step 2, and then your application will be in the step 2 state. So if we just look at the source code for this of what was changed, we see that in my cat component TS, I was pretty dumb when I first built this, and I set my base URL to be HTTP. So we want to make sure all of our links are HTTPS. So quick and easy fix. Just add an S there, and we'll kind of make sure that we'll pass that. Index.html, we see that I'm doing some initial styling on our body to remove all of the default margins. That way, our application, they'll get some paint before our style sheets actually render. And then inside of our meow root, we have a mocked nav bar where we're using the same color. It's just an empty nav bar, so we're giving it height and width. So basically what I did on that is into the application, I inspected, and then as you sort of look over your elements, you're able to get the height and the width on there. So I was able to replicate our nav bar and then make sure it's the same width, so there's not any jarring effect to the user when they're getting this app shell rendered to them. And then we just did a div where we did some initial styling, and we just have a loading indicator in there for them. So here, what you would do is you would probably find some CSS loading spinner or an SVG or something like that that is available here, and they're not required any like style sheets or JavaScript or images to load for this app shell. So you want to keep everything as simple as possible in this app shell. And then we have a no script tag. So if they don't have JavaScript enabled, it'll kind of fall back with just an H2 tag that says, hey, you got to have JavaScript enabled to actually view this application or this website. And then I added a HTML body for font size 16 pixels, which sadly gets overridden by the materialized CSS. So this really didn't do anything for my application. And I'll go ahead and check. Okay, there are no questions. And so if we go back to the presentation, so we made sure we did all of this, and then now we're going to perform another audit on our application. So we see now our numbers went up. Our progressive web app, if we look back at what it was, we scored a 36, and our performance was 70 initially. So now our numbers are, our web app is 55, so we have increased by 19 points, and now we have 100% performance. So just doing those small tweaks gave us all of that performance we needed for our application. And so we passed some more audits, but now we can do a lot better to make our application more scalable on the progressive web app audits. And if we look at performance, so now our first meaningful paint is about a second, and then our interactive is a 1.1 second. The interactive and the consistent interactive are in their beta phases. So I kind of see these numbers kind of bounce back and forth, all depending on like if you've already viewed that application in your cache, in your browser, and things are cached and stuff like that. I probably should have ran all of these in an incognito window with a fresh incognito window to get better numbers. So you'll probably see in the later stages of this performance kind of going down and all of that. It's mainly due to the GitHub pages kind of caching things as well. So we don't really get a decent score on our performance using GitHub pages. When you actually have this served up on your web servers and all of that, you'll be able to get more consistent results. So what we're going to focus on now is we're going to add a manifest. Basically what this manifest does is it'll just kind of, we'll set a whole bunch of properties for how our application works, icons, splash screens, colors, etc., so that we can be properly indexed by search engines and everything loads properly. So we're almost there. We have a few more things to do, and then hopefully we'll score 100 in all of the categories. So now we're going to update our application again. So during this update, we're going to add a manifest.json. So what is a manifest.json file? So this is a definition from the W3C. So web app manifest provides information about an application, such as the name, author, icon, description, etc., in a JSON text file. The purpose of this manifest is so that when you install web applications to the home screen of the device, it provides the user with quicker access and a richer experience. So when you set the description, icon, name, etc., when they save this to their home screen, it'll use that icon and display as that name. So it kind of looks like they installed it via the App Store, which is pretty cool. So what we're going to do on this one is we're going to create a source/manifest.json file. We're going to add some properties into it for icons, all of this. You'll kind of get these icons from your user experience, or you would make them yourself. We're going to head and modify the Angular CLI.json file to include this in the assets, so we make sure that it gets copied over to the dist folder when we build it. And then finally, we're going to update our index.html to add some additional meta tags. So let's take a look at what we did for him. we'll go to step 3. If you're following along at home, you can just do the git checkout step 3, and then you can see in VS Code or run it locally if you want to see what the code changes are. But we'll just look at in GitHub for now. So we see our angular.cli.json. We added the manifest.json into our assets. This makes sure that when Angular builds via the serve or the build commands, it'll copy it over to the disk directory for us. We just deleted the git keep folder that was in our assets. And then we added some icons inside of our assets for 16 by 16, 32 by 32, and 512 by 512. And you can add all of the different sizes into your icons as you need. Each device will use a different icon depending on the device size, the resolution, etc. So the more sizes that you have for your icons, the better your icons will actually look and feel when they're installed on a device. So we just have like 4 or 5 different sizes there to kind of show what you can kind of play around with. We went ahead and just changed the favicon in there since we had this pretty awesome looking cat. We might as well use that for our favicon as well. In our index.html, we added 2 new tags on there. So we added a meta tag for the theme color. This, if we look back at the slides of our failing, we see that there was no, the address bar does not match the brand colors. So this wants us to have a meta tag with the theme color that matches the same theme color in our manifest.json. So we added that theme color in there, and then we added a link that references to a manifest, and then we're saying go ahead and load the manifest.json file. So if we finally take a look at what we have at our manifest file, here we have the name of our application, a short name, so you can kind of do, if you have a really long name, you can shorten it. So depending on what device you install it on, it'll kind of display the short name or the name. We have a theme and a background color, the start URL, how the application displays when you load it up. So if your application needs to be in portrait or landscape mode, when they click on it to actually view your application, it can kind of start in there for it. And then all of your different icons. So here we just link to the source of the icon from our assets file. We have the different sizes, and then we use PNG. And typically you always want to use PNG for this type of these icons because they'll load faster, they'll be smaller, and your application will be a lot more performant. So now we go back to the slides. And so we added all of these things, we updated our index.html, and then now we do another audit. So you see, like, as we do more and more tweaks to our application, we can audit it at every single time to make sure that we're actually getting that performance out of there and we're increasing our numbers. So now we see that our progressive web app went up from about 55, now we're at 73, and now we only have 3 failed audits. So the 3 failed audits that we're missing now is we're not registering a service worker, we don't handle things properly when we don't have an internet connection, and since we don't have a service worker, there's no way that we can actually prompt the user, say, hey, do you want to save this to your home screen? They'll have to do that sort of manually through the menus and all of that if they wanted to do that, but we can give them a richer experience if we just add a service worker, and then that'll kind of prompt them when they go. And here's where I said earlier where the performance kind of goes up and down. It's mainly due to the GitHub pages, but we're still in the green, so that's pretty good. So now we're going to update. We're actually going to add a service worker. So what is a service worker? So a service worker, I think this is from the W3C standards too. So basically it acts as a proxy server that sits in between your web application and the browser. and the network when you have a network available. So basically what it does, it enables the creation of effective offline experiences, intercepts network requests, taking the appropriate action based on whether the network's available, and it updates the assets that reside on the server. So we can actually implement caching strategies and all of that inside of our service worker that'll sort of sit there and cache all of these things, so then you won't actually have to retrieve them from the server. And you can do a lot of fun things with this service worker. It doesn't really just cache assets. You can have it cache network requests and all of that kind of stuff that it'll kind of sit in there. And if the cache is available, then it'll serve it from the service worker cache and not actually communicate with your server. And there's cache budgeting strategies and all of that we can employ to make sure that we're not serving up stale data or anything like that. So what we'll do for this guy is we'll actually npm install a new package into our Angular project. We just do this by npm install add angular/service worker, and we'll save. We're going to go ahead and create an ngSTL-config.json file into our source folder, and then we'll make sure to include the service worker module in our app module, and then finally update our Angular CLI.json file. So if we look back at GitHub, and we'll look at step 4. So here in our Angular CLI.json, what was added was we add a new property in our application array, the application that we're working on for service worker and true. So basically, what this does is inside the Angular CLI, when it's doing all of the Webpack configs and all of that, if we're service worker, then it'll handle the bundling of your application a little bit differently. So we just need to tell the Angular CLI, hey, our application has a service worker, so bundle it appropriately. And then for some reason, the package.json, the spacing got changed, but the only thing that was added was this Angular /service worker module. And then in our app module, we made sure to import the service worker module from @Angular/service worker. We're importing the environment from the environment that we're building with. And then finally, in the imports, if we're in production, we're going to go ahead and register the service worker module with our ngServiceWorker.js file. And then if we're not in production, then we don't want to worry about bootstrapping up a service worker, so we'll just have an empty array there. So when we're in development mode, nothing will get intercepted or anything. The service worker won't even get bootstrapped. It'll only get bootstrapped in production. And then I'll go back to this one in a second. So our service worker config looks a little bit like what we had in the manifest. We have just a JSON file. We have an index property where we point to our entry HTML file. So right now this is just index.html, and then you have a different, you have an array of asset groups, and this asset group is basically how it handles caching and relaying all of these different assets. So here we have our app assets. So we're going to do an install mode. So we're going to prefetch these when our application's loading, basically the fav icon and the index.html, and then all of our versioned files. So all of our bundle CSS, our bundle JS, and our chunk.js files. And then we have a lazy install mode of our assets, named for our assets, where basically anything in our assets folder, we're going to go fetch them lazily instead of prefetching. So we won't block the rendering of our application or anything like that for things in our assets folder. And then finally, in our manifest.json, there's one audit where the start URL needs to be configured. And before we had the start URL as /, but it actually wants the start URL of your index.html file in order for it to be actually installed on your home screen. So I just updated this to be index.html. So if we go back to the slides, so we've done all of these steps, and then before we move on, there's a quick tip where when we generated this project, if we knew that we were going to generate the project with a service worker, the Angular CLI gives us a cool little flag that we can do where we can say ng new, whatever the name of your application is, and then --service-worker. And that'll automatically install the service worker package, wire it up in your app module. It'll create that ng service worker and kind of set up everything that we just looked at here. Like all of these files will be generated for you automatically. You won't have to know what to add. And then as you sort of familiarize yourself with more concepts of the service worker and the caching strategies and all of that and more things that you can do, then you would just append that logic to your service worker config file. Alrighty, so now we're going to perform the final audit of our application. And so now we see our numbers are a lot better. We actually have 100% on our progressive web apps. We only failed an audit where our page doesn't load fast enough on 3G. So this is actually bringing our performance score down, but it's an audit of a progressive web app. So things we can do to kind of improve that is the application loads pretty slow because of we have that image tag that loads the GIFs, and the GIFs are pretty big. So it kind of waits for those to render. And then finally, when the image loads, that's when it says we're good to go. So we kind of get a little bit performance hits on our stats there because we're using those GIFs, and they could be pretty big based on what the CAT API gives us back. So success, we did it. We created a Angular CLI. We added the app shell. We added the manifest.json, and then we actually created and registered a service worker. So there's some other considerations that we can do to sort of improve our application. We can actually set up our application to handle offline support. We can check the navigator.online property to see if we're actually online or not. And then if we say we aren't online, then what we can do is we can disable this button. So if they're offline, they're not able to generate a new CAT image here. And then we can tell the service worker to cache the requests that we're doing to the CAT API. So any request that we do, it'll cache the last result. And then so if we try to load up this application and we're offline, it'll just serve up whatever the last result was. And if you look at the application tab on the Chrome DevTools, you'll see that there's a service worker tab where you can kind of debug and check to see what your service workers are doing. This is actually the locally served one, so we don't do our service worker in dev mode. But when you're in production, you can kind of see the service worker. You can toggle it to be offline and all of that kind of stuff to kind of debug and kind of go through all of the different settings that we can set in the service worker. Going back to this guy, we can cache more external resources. So that CAT API was pretty small, but considering if like your application had a lot of metadata that you needed to go get before the application could load, and that metadata doesn't change a lot, we can use the service worker to say, hey, actually cache that request. So when the application loads over and over again, it's going to grab it from the service worker cache rather than actually hitting your network. So you'll save a lot of round trip and your application will load faster. And then we can compile with ahead of time compilation. We can use the build optimizer and all of that when we bundle our application. And then we can kind of just comb through our application, making sure we're using optimized images. We're not having a lot of bloated CSS, which I think a lot of cool things are coming down in like Webpack 4 when we can actually tree shake CSS and things like that to get rid of a whole bunch of CSS that they're not using, which would be pretty awesome. So all of these things you can do to kind of reduce the bloat of your bundles will improve your performance, and then it'll improve your, I guess, quote unquote, progressive web appiness. I guess I can coin that. So the summary of what we've done tonight, we created an Angular CLI project. We added an app shell that kind of just handled loading and mocked up our header. We added a manifest file that kind of described our application and how it will be installed on devices. We added service worker support for caching of our assets and handling some offline support where if our application was offline, we can disable buttons and all of that kind of stuff. And there's a lot of advanced things you can do with offline support where you can kind of remember all of the actions the user took and then replay those when they actually come online and then kind of save all of your states. I don't know if anyone's kind of used like Google Docs or anything like that when you're run out of when your Wi-Fi gets disabled or something like that, you're able to still work, and then when you get a connection, then it properly syncs. So a lot of that's done via like a service worker. So any questions? So at this point, I'll just unshare my screen and then just look at the chat. If I can find the things. So hope everyone learned some stuff. And if you have any questions, just put them in the chat and then we'll kind of wait a couple more minutes and then I'll end the Hangout. So we have a question for, does the audit cover any vulnerabilities? I guess a vulnerability that it could grab it would be like if you're not using secure connections like HTTPS or if you're mixing protocols and all of that. But for the most part, it will capture the performance, like load times and all of that, not really not like a vulnerability test. And for the next meetup, we'll probably, hopefully, I'll see if I can get one scheduled for February. But if I can't get a speaker, it'll probably get pushed to March. And I'll put all of the slides and all of that on the Hangout, or not the Hangout, but the meetup link. And then if you have any other questions or anything like that, just go ahead and put them on the meetup website on the discussion board, and then I'll kind of answer them when I get time. But thanks everyone for joining. Hope this this first live stream only Hangout went pretty good. Thanks everyone.